welcome to my YouTube channel. Again, today we are diving into another interesting topic in data structures and algorithm, that is recursion. So, here, what is this recursion? Recursion means that in a function or we have to do some repeated code parts. So, if we are calling a function again and again, this will be very helpful. So if we are using a loop for do that, it will be many more line of codes. So here within the recursions, it will be easy by 2 or 3 lines. So what are the advantage of this recursion? Recursion gives us more readability and very simplicity. If it is easy to read the code without going to scrolling down and many pages. There are few lines of code in recursion when we are using recursion, but some problems are here within related to the recursion. Some of them are sometimes the effectiveness of recursion is very low, uh, and because the memory usage of that, uh, we need more stacks for save these recursions. Sometimes the stack overflow errors will become due to this due to using of recursion. So let's move on to a important example within this recursion that I think you will ask about this in your small in your child in when you are a child. I think you will definitely hear about this, that is Hanoi problem. So let's dive into it. Okay, as you can see on the screen, we are diving into Hanoi problem. This is a game actually. I it definitely you were played in your uh, child time. So this is a usage of recursion. So let's see how to do this. Here there are some rules. One of the rule is we can't move more than one disk at a time. Okay, I think you can understand it. We can't move one and two together. So another rule is second rule is we can't put uh, higher weight disk into a higher weight disk under a upper upper side of the lower one. Okay, I think you can understand it. We can't do this if we are go to put one here b, we cannot put two on it. Okay, so our game our target is to put these 1 2 3 into here C. So we can get the help of this B to do it. So let's see how to do it within the minimum moves. Okay, we are using minimum moves. Okay, min. Okay, let's do this. Here you can see we are moving one containing disk, the lowest weight disk, to C. So as you can see on the screen, it moved. Next, the second disk to B, A to B. Our move is to A to B. Okay. Then C to B. What is this C to B means? We are going to put first disk on the second disk. Okay, as we are not violating any rules here, because first disk is lower weight than the second disk. So then we are going to put the third disk into C. Okay, then what we'll do, we can't easily we can do this. Do you think this two can perform put into this scope? No, you can't, because you can't move two disks at a time. You can move only one disk at a time. Okay, then let's see what will we can do. I am going to do this on B to A. I am doing I am going to move first disk B to A. So there is no problem, we are not going to violate anything. So next we are moving second disk from B to C. So here, so next first disk can move to here easily, because it is a single disk, and we are not violating anything, because these two are always higher weight. So let's see next step, A to C. Yeah, so as you can see on the screen, we did this in minimum moves. There are 7 steps actually. So here how we can do this using a pseudocode, and what is the logic and steps inside here. Let's see about it. So as you can see on the screen, this is the pseudocode part. So here Hanoi means this, we are using the recursion here. So how to do this within the recursion? So we are calling this function again and again inside that function. Okay, n means here the number of disks. Okay, until the number of disks are equal to 0, this will be run. So let's see what will happen. So firstly, we are here and here are same, both are the same function. Here n means 3, we have 3 disks. So here a means the source here. So auxiliary here is what? B. Okay, here we are going to call it. Okay, so the destination is what? C. Okay, let's see what will happen. Then we have 3 functions within this recursion. Okay, three lines here within this recursion. It runs two lines in recursively. So let's see. Then we have 3 lines. So for 3 lines I have arrowed with 3 places. So second time we are calling it by this n minus 1. Firstly n equals to 3. So here n equals to 2, because this is n minus 1. Okay, then source is here, source is same as here. So next the auxiliary becomes destination here. Okay, auxiliary and destination becomes changed. Okay, I think you can understand it. So C and B interchange here BC, and here comes CB, because these because here you are calling with source, auxiliary, destination. Here firstly you are doing source, destination, auxiliary. Okay, then move disk source to destination. Okay, then what will happen? A to C we are going to do this one. Okay, then Hanoi to BAC. Hanoi. Hanoi means the function we are again recursively call with n minus 1 or auxiliary. This should be auxiliary. Okay, x, there should be x here. Auxiliary source destination. So in that order we are doing it. Okay, on that order means what? Here this is the way, this is the actual truth one. Source is A, auxiliary is B, and destination is C. So here we are in the third line. This is the third line. Okay, this is the second line. Okay, this is the first line. Okay, so in Hanoi to BAC means auxiliary. Here auxiliary means B. So here this comes as the B comes as the auxiliary. So next A is the source, because here is source is A. So A becomes as so, and the destination means destination becomes C. Destination not changed. Okay, until n becomes 1, we can do this one. Okay, Hanoi 1 until n becomes 0. Actually here n equals to 3, n equals to 0, we can do this recursively. So as you can see on the screen, we are going to do it here. After n becomes 1, we can't do again this process, because n becomes after we calling here, n becomes 0. Okay, then n becomes 0 and we are recursively called to this function. So if then n here n becomes 0. So here this one working only if n greater than 0. So let's see what will happen. Only the second line second lines one will be doing here, because only the moving part will be doing here without these Hanoi and these parts. Okay, I think you can understand it. So here always coming like this. These are not coming Hanoi first or second or only the second line will be called, because we can't do these two, because when n equals 1, here they are n, here they are become 0. Okay, okay, as you can see on the screen, until n equals 1, you can do it. Okay, see. Okay, I think you can understand this one. Here A to C, A to B, C to B, A to C, B to A, B to C, A to C. So if I am going to connect these C to B moving parts, so here you can see definitely there is when what I show before you, I will go to previous slide, and you can see here, you can see that this is that order. Okay, here is the recursive method. Here is the recursive method. After we can implement it into the Hanoi problem. Okay, so I think you can understand this. So let's come with another video on another day.